Look at us, we're back, baby. Write the simplest polynomial function with zeros, -2, 2, and 4. Now, if -2 is one of our zeros, when that's in factored form, that would show up as x plus 2. If +2 is a zero, that would show up as x minus 2. And if 4 is a solution, that would show up as x minus 4. That's it, but we just have to multiply this out now. When I'm multiplying this out, I look for a few things. Now, we can multiply them in any order, but I look for difference of squares because then you don't have to FOIL out everything. If you have a difference of squares, remember you square the first term, you put a minus, and you square the second term. 2 squared is 4. Now we just need to multiply this x squared minus 4 with another x minus 4. So now we can FOIL it, first, outer, inner, last. Or make sure you multiply everything from one set of parentheses to everything in the other. X squared times x is x cubed. X squared times -4 is -4x. Squared, sorry. Now we're distributing the -4. -4 times x is -4x. And -4 times -4 is +16. And that's it. That's not too bad, huh? Now, you could write something like p of x equals, or whatever, but that's fine, that's it. Dare we try another? We shall. Write the simplest, oh, this is for you to try. So why don't you pause it here, try it out. You want to write one with the zeros of 1, 2, and -4. Try it out. All right, 1 would be x minus 1, 2 would be x minus 2, -4 would be x plus 4. There are no difference of squares. It doesn't matter the order we multiply them in. Let's say I paired up these last two. That would give me x squared plus 4x minus 2x minus 8. I would combine my x's together, and we would have x squared plus 2x minus 8. We still got to multiply that by another x minus 1. So if we distribute the x to all of them, it's just going to bump up everything 1 degree. X to the third plus 2x to the second minus 8x. Now we're going to multiply by -1, which just makes everything the opposite. -x squared, -2x, and plus 8. Combining our like terms here, we have x to the third plus x squared minus 10x plus 8. There it is, folks. That wasn't too bad, huh? Hopefully you did a good job on that one. The fundamental theorem of algebra states that the degree is the number of zeros that we're looking for. We've been talking about this. So if you look at this function has blank solutions. You look at the degree here, the highest exponent is 11. So it has 11 solutions. Now, you might not have 11 different numbers, but if you have something with like a multiplicity of 4, that counts as 4 solutions right there. Now, if it's set up like this in factored form, each place you see an x would be like a solution. So you would look at the exponents. So here would be one solution because it's to the first power. Here would be a second solution. So 1, 2, this one's got 3. So that would be 3 different solutions there, or 3 solutions. And then this one just has 1. So if we add up all those exponents, there's 1, 2, 3, 4, 5, 6. There's going to be 6 solutions on this. Yeah, even though 5 would be the solution 3 times, we still have to count it as 3 solutions. All right, so you look at example 3. We're looking for 4 solutions because it's to the 4th power. So we're going to have to check some stuff with some synthetic division, and we'll have to get it down to a place where we can then factor. You could do synthetic division the whole time, I guess. Maybe. But that would be a lot of time. So we have 1x to the 4th, 4x to the 3rd, -1x to the 2nd, 16x, and -20. We're checking factors of 20. which could include 1, 2, 4, 5, 10, and 20, the positive and negative versions. Let's try 1. Once we find 1, then write it in your notes, just to save some time. So let's say we went with 1. 1 times 1 is 1, 4 plus 1 is 5. 1 times 5 is 5, minus 1 is 4. 1 times 4 is 4, plus 16 is 20. 1 times 20 is 20, so this one does 0 out. So go ahead and jot that down. So if 1 is a solution, and again, I know I'm going quick, but pause the video to write it down. 1 is a solution, so in factored form that would show up as x minus 1. Now what we have left, if we started with x to the 4th, this would be 1x to the 3rd, plus 5x to the 2nd, plus 4x plus 20 equals 0. You could keep going with some synthetic division. However, here's things to look for. See if these two terms and these two terms are proportionally equivalent. 1 times 5 is 5. Is 4 times 5 20? Yeah, it is. So that's a good indicator that we could do some factoring by grouping, which I would prefer over testing more numbers with synthetic division. So we could split it down the middle here. X cubed and 5x squared have x squared in common, leaves us with x plus 5. 4x and 20 have a 4 in common, leaves us with x plus 5. So that part would factor to x squared plus 4 times x plus 5. Over here we have the x minus 1. So it is factored as far as we can go. We can't factor x squared plus 4 anymore because it's not the difference of squares. So now go in solutions, and again, we have 4 solutions. Here's one of them, x equals 1. It has a multiplicity of 1 because it's to the first power. The x plus 5, x equals negative 5. Again, has a multiplicity of 1 because it's to the first power. That's only 2 solutions. Our other 2 solutions are going to come from this x squared plus 4. Now, with these, it's easy. It's just opposite. X minus 1, positive 1. X plus 5, negative 5. But what we're really doing, and we're just kind of shortcutting with those, is we're setting an equation equal to 0. We're doing x squared plus 4 equals 0, and we're solving that. We've solved problems like that before. You would subtract the 4, and then to get rid of x squared, you would square root it. Now, when we square root numbers, it gives us 2 solutions, unless you're square rooting 0. So we would say x equals plus or minus. We're square rooting negatives. We got to dip back to that imaginary number system. Square root of 4 is just 2. Square root of negative 4 is 2i. So we would say plus or minus 2i. So that would be 2 solutions. Positive 2i, negative 2i. Here would be our 3rd solution, 4th solution. It was to the 4th power. They're tough, man. They're tough. But you can do it. Let's try some more out. Let's see what we got. Now, if you look here, we can square root both of those, and it has a minus in the middle. So we'll have a difference of squares. Square root of x to the 4th is x squared. Square root of 81 is 9. So we'll have x squared plus 9 times x squared minus 9. Now, technically, if you want, we'll factor it all the way first. You can't do x squared plus 9 anymore. It's not a difference of squares. But x squared minus 9 you can. That would be x plus 3 times x minus 3. Again, we're looking for 4 solutions here. So x plus 3, x equals negative 3. There's 1 solution because it's to the first power. X minus 3, x equals positive 3. That's 1 solution because it's to the first power. Here we have x squared. We're going to have to do some work. X squared plus 9 equals 0. You would subtract the 9, and then we would square root both sides. You're square rooting, so put plus or minus. That would be 2 solutions, positive whatever, negative whatever. Square root of negative 9 we would say is 3i. There are our 4 solutions. Positive 3i, negative 3i, negative 3, positive 3. Whew. Brutal. Now, I was starting to say this earlier, but technically on this pink step, you could start solving from there. If you were just solving it, that would be fine. But when you're graphing, you're probably going to want to factor it out all the way. But you could set up your equations here. You could be like x squared plus 9 equals 0, and x squared minus 9 equals 0. We did the x squared plus 9. Subtract your 9 first, and then you square root it, plus or minus 3i. Over here you would add the 9 first, and then you square root it. Square roots of 9, you'd say would be plus or minus 3. That's two solutions. Hey, positive 3, negative 3. Shows up either way. We got one more, I think. Oh, here it is. And then there's one for you to try. So, all right. The nice thing about this one is if you look at that last term, it's just 1. So we just have to test either 1 or negative 1. Those are the only factors of 1. So if we're doing synthetic division, and we write our numbers across the top, 1, 3, 3, 1. The only two possible numbers to test are 1 or negative 1, because those are the only factors of 1. Now, these are all positive currently. If I multiply by positive 1, it's just going to get bigger and bigger. So I'm not even going to test that. Negative 1, it better work out. Negative 1 times 1 is negative 1. 3 minus 1 is 2. Negative 1 times 2 is negative 2. 3 minus 2 is 1. Negative 1 times 1 is negative 1. It zeroes out. So we have one of our zeros. Our 0 was negative 1, so in factored form that would show up as x plus 1. Now what we have left here, it started x to the third, so this would be 1x to the second plus 2x plus 1. Here's what we got. We're trying to factor. Factors of 1 that add up to 2 would be 1 and 1. So we got x plus 1 times x plus 1 times x plus 1. They're all the same. And there's 3 of them. So we would clean that up and make it x plus 1 to the third equals 0. So we're only going to end up with one solution here, negative 1. But it's to the third power, which means it has a multiplicity of 3, which again comes into play once we start graphing these. We were looking for 3 solutions. We got 3. It's got a multiplicity of 3. So there's one for you to try. Here it is. Pause it here, try it out, see how you do. I'll try it up here, and we'll see if we kind of match up. Let's see. 1, 1, 2, 4, negative 8. 1. Out. So that would be x minus 1. This would bump down to 1x to the third plus 2x to the second plus 4x plus 8 equals 0. If I was legitimately doing this myself, I would check if these are kind of in the same proportion. 1 times 2 is 2, 4 times 2 is 8. That will mean I can do factoring by grouping. So if I group those, these have x squared in common, x plus 2. These have a 4 in common, x plus 2. So writing that then in factored form, we'd have x squared plus 4. We'd have the x plus 2. We also have to bring down this x minus 1 from earlier. That's as much as we can factor because that's not a difference of squares. So we'd have x equals 1, has a multiplicity of 1 because it's to the first power. X plus 2, that x equals negative 2, also has a multiplicity of 1 because it's x to the first power. This one, we're going to have to solve an equation. X squared plus 4 equals 0. Now, we've solved this equation already today. We subtracted the 4, and then we square root it, and we say x equals plus or minus 2i. So we got positive 2i, negative 2i, positive 1, and negative 2. And that's just how we do.